Welcome to the PXRD training module. In this training module, I will cover the basic operation procedures of the Pananalytical Expert Pro XRD machine at the shared facilities. Our PXRD instrument locates at the Engineer Research Building, room 211. The entire system consists of a main PXRD unit, a chiller, and a computer that operates the machine. This yellow dome-shaped light on top of the PXRD unit indicates the status of the X-ray tube, and it should be on all the time. For safety reasons, all the XRD systems are closed beam system, so users won't be exposed to any X-ray beam. For our system, all the measurement components are fully enclosed inside the hutch and could be accessed after opening this sliding door. While that door can only be opened after closing the shutter of the X-ray tube. This outside display panel shows the instrument angle, the X-ray tube power setting, and the X-ray tube shutter sliding door status. For the X-ray tube power setting, it should be either 45 kV 20 milliamps at a standby mode or 45 kV 40 milliamps during the measurement. For the shutter sliding door indicator, it should be either no display, which means both shutter and the door are closed, or a small dot there, which indicates the shutter is closed while door is opened. This will allow you to install samples and modify X-ray optics before the measurement. Finally, a number 1 there, which means the shutter is opened while the door is closed. This is the situation during your measurement. There should be no shutter open and door open situation, since the user will be exposed to the beam in this situation. And also the system safety interlock will prevent this situation. With the X-ray tube shutter closed, you could access all the measurement components inside the hutch after opening the sliding door. Here is the image of the instrument inside the hutch, which includes 4 key components. The X-ray tube with the shutter attached to its exit port, the spinner sample stage, the X-ray detector, and the automatic sample changer, which will load and unload the sample from the stage. There are also X-ray optics between the tube to stage and the stage to detector. Those X-ray optics will shape the incident X-ray beam and the scattered X-ray beam to optimize the measurement X-ray signal. Now let's talk about the sample preparation. The sample preparation bench locates at your left-hand side after entering the lab. Here I have a few photos to show the bench itself and the tools you will use to prepare the powder samples. All those tools are on the sample bench. Now I will show you how to prepare powder samples. If you have a large amount of sample, then you could just follow the standard sample preparation procedure on the workbench to load your sample using the sample preparation kit as shown in the video on the left-hand side. Mount the top plate onto the sample preparation kit. Then backloading the powder into the opening space. You may press it down. Just try to make the powder compact. After that, remove all the excessive powder. Assemble the whole holder, and then flip everything over. So now you have a sample for the measurement. If you have small amount of sample, and then you could use glass slides in your sample preparation procedure. The video on the right-hand side shows you how to prepare your sample using glass slides. Here we start with the whole sample holder, and then we apply a small piece of Play-Doh to the center of the opening space. And then add a piece of glass slide right on top. Make sure it will also fit into the opening space. And then use this glass slide to make sure the glass slide surface is still flush with the top piece of the sample holder. Then you could apply a small amount of sample on top of the glass slide. And then make it a nice flat surface. Again, the key point here is to make sure the height of the sample surface is in flush with the top piece of the sample holder. Notice that both Play-Doh and the glass slide are amorphous, so it will not create any XRD peaks during the measurement. Once you have your samples ready, you will need to load your samples onto one of those 3 sample magazines. We usually start with magazine A, the one on the right-hand side. The top position is called A1. The next one is A2, then A3, etc. Here is a video to show how to load the samples. Protect your sample surface when loading them, and also make sure those samples perfectly sit into each position. Here I load 3 samples from A1 to A3. After loading samples, gently close the door, then we could move to the computer. The software we are going to use is called the data collector. On the computer desktop, locate the software icon, then double-click it. In the login window, use USER user as the username and SRF as the password to enter the interface. Then go to the Instrument tab, Connect to build the connection between the PXRD machine with the computer. So here, a dialog window will come up for stage configuration selection. Please select spinner from the list, then click OK. This will load parameters for the spinner sample stage, which is used for powder measurement. The lower right corner is a bar to show the loading process. Another dialog window will show up, which will contain the information about the current instrument configuration. Please just click OK to continue. Eventually, you will end up with the interface, which will allow you to access the instrument setting parameters, the incident beam optics parameters, and the diffracted beam optics parameters. Do not change anything at this point. For this system, most of the measurement actions will be executed through a specific programs, so you do not need to do anything through this interface. Before we create measurement programs, let's take a look at the setup of X-ray optics. The goal of this step is to optimize the measurement signal by matching the X-ray beam size with your sample size. Here, I zoomed into the X-ray optics on the incident beam side from the X-ray tube to the sample, and the X-ray optics on the diffracted beam side from the sample to the detector. The first component we need to check is this beam mask on the incident beam optic side. Yeah, you will see this copper disc with a wide opening. This copper disc will determine the width of the X-ray beam on your sample. We have 4 beam masks with different opening size, from the smallest to the largest, labeled as 5, 10, 15, and 20. For standard sample preparation, please use mask number 20, while for the samples using the glass slice and Play-Doh method, please use mask number 15 to get the best result. Here are videos to show you how to remove and insert beam masks. To remove a beam mask, use a special tweezer and simply pull it straight up. To insert a beam mask, put it into the slot first, and then gently press it down into place. The tweezer and the spare beam masks are all in a plastic box inside the hutch on your right-hand side. After changing the beam mask, please gently close the sliding door. Beside this beam mask, there are two automatic programmable slits. The divergent slit on the incident beam side and the anti-scattering slit on the diffracted beam side. The divergent slit will determine the X-ray illumination length on your sample, and the anti-scattering slit will determine the X-ray collection length from your sample. Those two slits are exactly the same type of device, but on the different side of the sample, and they are controlled by the data collector software. To check the slit setting, go to the data collector software. For divergent slit, click on the Incident Beam Optics tab and then check the angle value of the programmable divergent slit. A slit size of fixed mode ½ degree is recommended for the normal operation. Then go to the Diffracted Beam Optics tab and check the angle value for the programmable anti-scattering slit. The same fixed mode ½ degree angle is recommended for the normal operation. Now we are ready for creating measurement programs. You will need to create two programs to run the measurement. The absolute program, which contains all the measurement parameters, and the batch program, which contains a set of commands, including X-ray power setting, sample loading, and call the absolute program for measurement. To create a new absolute program, go to File, New Program, and choose Absolute Scale. Before you change any parameters, go to Setting tab first. In this window, choose the detector to be accelerator detector. That's the default detector we are using. And also set the spinner speed to be 4 seconds per turn. That's the recommended spin speed. So now type in the start angle, end angle, angle step, and time per step. Notice that because we are using a multi-channel detector, the system will automatically adjust those proposed parameters to the nearest allowed value. For example, so when I type in 0.02 degrees into the step size window, the system will automatically change it to 0.0167. So here the measurement is very short, it's only 1.5 minutes. But usually a normal measurement will take about 10 minutes to 30 minutes. So you will need to choose a proper time per step number until you get a measurement between 10 minutes to 30 minutes. Once you have all the parameters ready, just go ahead, close it, and save it using your name. Here I'm using training video, then underscore absolute as the file name. So now let's create a batch program. This batch program will contain all the commands we want the PXRD machine to execute. So we start with the power up command, which will bring the X-ray power up to 4540, and then we will load the first sample, usually A1. After that, we will call the absolute program to do the measurement. If you have more than one samples, and the next one will be load the sample after. And then number 5 will be call the absolute program again to do the measurement. If you have more than 2 samples, you just need to have a loop setting to repeat number 4 and number 5 multiple times until you finish all the measurement. Finally, you will have a command to bring the X-ray power back down to 4520. That will finish all the measurement. If you only have 1 sample, then you might just remove 4 and 5 in this list. Just have 4 commands: power up, load sample, measure, power down. That's it. Okay, to create the batch program, click New Program, select General Batch. And then make sure you choose spinner and then click OK. So here we'll insert command one by one. Let's start with the batch settings. The first one will be power up. So go to X-ray tab, set power to 4540. The second one will be sample loading. So go to the batch setting again, choose sample changer, check sample position, and just set position to be A1. The third one will be insert measurement program. So here, just looking for the absolute program we just created. Open that one up. Choose a proper folder to save your file. If you will do it first time, then you will need to create your own folder. Click OK. So now let's go to next sample. Batch setting again, sample changer, sample position. Let's select increment. That means we just go to the next sample. Then call the absolute program again. And also choose the proper folder. Save it. So finally, we will bring the X-ray power back down to 4520. If you have more than 2 samples, as I mentioned earlier, you just need to repeat number 4 and number 5. Here, you push the control button and select 4 and 5 at the same time. And then click the cycle button to choose the proper cycle time. Because we have 3 samples, I just need to repeat 4 and 5 2 times. So including A1, we will have 3 measurements to cover all 3 samples. Then close this file and save it as your name underscore batch. This will be the batch program we will use to make the measurement. Now we are ready to run the experiment. To start measurement, go to Measure, click Program, and then choose the batch program we just created. Open it, and then in this Start window, review the measurement. Make sure we got the correct number of samples, and also we got the correct position of those samples. At the bottom, make sure this unload sample after the batch has finished part is checked. Then click OK button. So now we start measurement. The system will execute the batch program one by one command. So bring the power up to 4540, load the sample, reposition the arm, and start measurement. So here, the shutter indicator shows 1, that means the shutter is open, and we have X-ray in the hatch. And then the result will show up here. So this is the PXRD result from the silicon calibration sample. So once this measurement is done, the system will automatically go to the next sample and load next sample and start the measurement. So once all the samples are measured, the system will unload the last sample and bring the power back down to 4520, and then the measurement is done. Once you've finished all the measurement, make sure the XRD machine is back down to the standby mode with 45 kilovolt 20 milliamp setting, and the shutter is also closed. Then you could disconnect the instrument from the computer by selecting Instrument, Disconnect, and click OK in this Close Control Form window. So all the parameters will disappear from this window, and you could go ahead and close the software. Now, you could go ahead, open the sliding door, and remove the sample from the magazine, as shown in this video. Remember to close the sliding door after removing all your samples, and then you can go ahead to clean the sample holder. You could open the raw data file using the Data Viewer software. The Data Viewer software will also allow you to convert the raw PXRD file into different formats. And the most common format is the CSV file, and could be opened using the Excel after the conversion. After clicking the conversion button, a new file will show up in the same folder as the original file. Then you could send both raw file and the CSV file to yourself for further data analysis. Here is a quick summary about all the key steps of operating the PXRD machine. And this will also conclude this training module.